Good morning, students. Today let us see regarding the IP version 4 header format. So we'll briefly discuss regarding the IPv4 header format and what are the questions asked in GET, mostly the problematic questions that are asked in GET. So we'll not go in depth about this header format. I've given the notes for the description of all the fields in the header format here. So this describes the version number. If it is 4, since we are discussing about IP version 4, so this will describe the version number 4 here. So it is of 4 bits, and this 4 bits will describe the version number. Next is header length. I'm just giving the overview, not the in-depth descriptions. Header length describes the length of the header. The length of the header. Here I have told you every packet will accompany it with the data, and the header part. And this header part here. This is your header part, and the length of this one will be of 4 bits here. So this is given by the header length. So type of the service, it describes the quality of the services given by these packets. The total length. Total length is the combinations of this header along with the data here. Means your payload, we call this data as a payload also. So we call this total length is given by the additions of the length of this data and that of the header. Means the total length is given by header plus the length of the data here. Since it is of 16 bits, the length can be of in the form of to the power 16. The length of the payload can be of to the power 16 here. The next field is the identification. This of 16 bits. This particular second field will come into picture only in the fragmentation part here, IP fragmentation. So that is what I want to concentrate in this particular field for the given GET problems. So means when a packet is fragmented into smaller parts, then in order to identify them that they belong to a particular packet, so we have given the identification number, and this identification number is of 16 bits here. We have particular 3 flags. The reserve flag is always set to 0. We have DF flags and the MF flags here. DF stands for don't fragment, and MF stands for the more fragments. If the DF flag is set to 1, it means we need not fragment the packets here. In spite, if the packet is large enough, if it cannot be transmitted through a particular channel, because if it exceeds the maximum transmission unit, if the DF flag is set to 1, then we have to discard the packets here. We cannot fragment it. So you have to look at the questions whether the DF flag is set or not. If the DF flag is set to 1, then we should not fragment it. If the size is less than that of the maximum transmission unit, then we have to transfer it without any fragmentation. Otherwise, we have to discard this particular packets here. And if the DF flag is set to 0, means it can be fragmented. DF flag means it can be fragmented. The next part is the more fragments. More fragment means if the particular more fragment value is set to 1, it means that we have other packets to be, the part of that packets needs to be fragmented. If it is 0, if MF flag is 0, then it means that it is the last part of the fragment here. There are no fragments left out in a particular packets here. So this is the fragment offset. Fragment offset, as you know, is a displacement of the particular fragment from the unfragmented flags. So we need to concentrate in this particular fields here. In the GET questions, you will be given a problem and you have to identify the value for the fragment offsets, or maybe the starting of the fragment, and what is the value for this more fragments and so on. Okay, so next field it's the time to leave what we have discussed in the notes, the protocols, the header sections, in order to check whether there is any error during the transmissions. And this is what we have: the source address, the destination address, and options and the data here. The descriptions of everything I have already included in the given notes. So let us see a particular problem, how is it asked in the GET questions. So in the GET question, it is asked, in an IPv4 datagram, the M bit is 0. The value of the header length is 10. The value of total length is 400 and the fragment offset value is 300. The position of the datagram, the sequence number of the first and the last byte of the payload respectively are. This is asked in the GET 2013. So we given such kind of problem, we have to find the positions of the datagram. What is the position of that particular datagram, whether this is the first fragment or the last fragment. We have to check what is the sequence number of the first and the last byte of the payload. First, we have to find these 3 points here. So what is given in the questions? We have in the questions the header length is already given. The header length is 10. The header length is 10 means the total size of the header. When given such kind of problem, you can solve that. The header length is already given as 10 here. From that you can calculate the particular size of the header. 10, what is the number of bits? Here it is 4 bits. So this is of the size of the header is 40 bytes. The size of the header is 40 bytes. And also given here the total length. The total length is given as 400. It means in our packet this is already 40 and the total length is given as 400. It's given as 400 here. So you can easily calculate the value of this data. What is the value of this data or the payload is given by 400 minus 40 equals to 360. 360 is the size of the data or the payload. Next, what is given? The fragment offset is already given as 300. So when the offset value is given as 300, in order to find the positions of the datagram, the sequence number of the first fragment, we need to simply multiply the fragments with 8, because the offsets are always in terms of 8 bytes. So this is of 2400. So the positions of the first, the sequence number of the first byte in the payload is 2400. Next, if this is the size, then what will be the last ending part, the ending byte? Ending byte will be, this is the beginning, what will be the last? If I want to find the last 10, I have to add 2400 plus the size of this payload minus 1, since we have started counting from 0. So this is 2760 minus 1. It means this is 2759.